Let's get started now. Let's understand what is Azure and what is Azure data engineering. What we do at our job desk. Let's get started step by step. One of the trending technologies and of course highly paid job profile. What is data engineering? Before that, what is database? A platform to store any type of data, any amount of data, no exceptions, no restrictions, fully secure. And we have two types of databases: OLTP databases, OLTP, online transaction processing database. These databases are used to store live data, real-time data, like a live cricket match, live temperature, live stock market operations, so on. These OLTP databases, developers will take care. You and me, we are into data engineering. We'll be involved in data warehouse. Means to store historical data, inactive data. What is it? Historical data or inactive data. So we are into big data operations, like a godown warehouse. Data warehouse is nothing but a godown. So we'll be involved in something called ETL process to design this godown. Okay, what does it mean? On my screen now, here it is. Any end-to-end implementation involves right from data extraction. See here, we are extracting data from various data sources. It may be files, web, IoT, Internet of Things, part of our classes, apps. We are going to learn about web apps and desktop apps, web apps and desktop apps, and other cloud sources. We are going to read data using ETL, extract, transform, load, and place the content into warehouse. It can be a data warehouse or a lake house. Lake house is a combination of table storage data warehouse and file storage data lake. Usually, data lake is a place to store historical files, old inactive data. Data warehouse to store old inactive tables, table format. So tables and files mixed together, we have lake house. So our course is into all these ETL structures and all these warehouse or the big data storage structures. The birthplace of data, various data sources. Data would be first going to OLTP, live online transaction processing databases. From there, we read data, extract and load it to storage. In few cases, we need to get the content directly like this, in this way, bypass the OLTP. So we need to learn both database data loads and non-database data loads given to the ETL and eventually to warehouse. This is our actual classes, data engineering. In a more simplified way, data engineering is all about reading data from databases and non-database sources. using ETL techniques, extract, transform, load, and get their content to warehouse. Now things are very simple and straight. In ETL, there are two options for implementation: open source, Microsoft. Data warehouse also two options, again open source, Microsoft. Okay, total 4 items we need to learn, 4 combinations we need to learn. What are these open source and Microsoft will understand now. In our data engineering job roles, it involves number 1, the data engineering job role involves number 1, big data, cloud computing, ETL, extract, transform, load, data warehouse, and lot more components. And in our classes, we'll be working with various components practically: Azure SQL, Azure ETL and warehouse, Azure Data Factory, Synapse, Databricks, Data Lake, IoT, Event Hubs, Key Vaults, and Stream Analytics. And we need to learn something called Azure Insights, Key Vaults with Insights, Key Vaults with Event Hubs, one version, Key Vaults with Insights, another version, logic apps, functions, purview, integrations, and end-to-end project. This is a complete length of our course. In this journey of 17 items, we need to have certain derivatives, AI components, Spark, Hive, Python, PySpark, and Scala, with something called Unity Catalog, a big data store concept, ETL, ELT, automations, and AI integrations. And to implement 18 to 27, we need something called pipelines and notebooks. Automate them using CI/CD and Git configurations. FAQs, resume guidance, certification part, guidance part. I'll take care. I'll send you all this list today after the class. I request you to document it for easy future reference once we start our journey from tomorrow. Things are a bit lengthy, but yes, will be useful. In our classes, we'll be having, I said, 2 items, right? 2 open source, 2 open source technologies, one for ETL, one for warehouse. And 2 Microsoft technologies I told. One for open source, one for Microsoft. What are these? Let's see. On my screen now. We are into Azure Data Factory, Microsoft ETL, and Azure Databricks. So open source databricks.com environment, ADB. So there are 2 ETLs now, one Microsoft, one open source. Same way, 2 warehouse platforms, one Microsoft Synapse, open source Spark. There are other warehouses as well, like Amazon Redshift, Snowflake. Snowflake usually depends on DBT, data build tool, and Snowpark. So Snowpark, data build tool, Snowflake, one combination. Amazon Glue, Amazon Athena ETL with Amazon Redshift warehouse, AWS engineering, another combination. Our course is into Azure data engineering, the green bordered items. So we'll start with ETL from tomorrow and need to step into warehouse concepts. So we have Microsoft ETL, Microsoft Warehouse, open source ETL, open source warehouse. Again, there is a combination, combo. ADF can push data to Spark database as well as Synapse. It is possible, but this is highly recommended. These two are good friends. Their architecture match in multiple cases, multiple ways. Same way, Azure Databricks good friend, Spark. But in our examples, we need to learn this item also. And further, again, these two are good friends. Data Factory and Databricks. These are again good friends. I mean, it's like a thali, you know, we cannot see the components isolated. They have to be mixed some way or the other. Either outside or inside, they will be mixed. It's like a thali, the complete green plate. So Azure Data Factory, a prominent Microsoft ETL, has a lot of benefits in terms of number one, performance, number two, free support, number three, easy user interface. Azure Databricks, on the other hand, has its external dependencies from an open source environment called Databricks. Databricks is an open source environment. From there, we have Azure Databricks. It has nice advantage in terms of machine learning, data science projects, AI implementations, and very recently came RPA, robotics process automation libraries also in ADB. So even RPA projects started to use Azure Databricks now. These two are dependent in few aspects. For example, Azure Databricks do not have the end user prompt for entering the credentials or dynamic connections. Data Factory has that prompt. Data Factory lacks data science components. Databricks have it. Synapse has nice advantage of row level security, column level security, usernames, logins, etc. Spark has good amount of performance benefit towards big data processing. Cheaper, very, very cheap compared to Synapse. So each of these have their own advantages and we need to see them like a meal, a weekend meal combo. Really, let me justify my statement with one website link on my screen. I said Databricks separate company, right? Here it is. From there, let me show you the friendship between Data Factory, Databricks. Here it is. Data Factory is well known to read data from unstructured content and structured content. Databricks is known for its caliber, for its talent to read data from IoT devices and semi-structured content. At the end of the day, both Databricks content and Data Factory content will be coupled together, combined together, and load to Synapse. What is Synapse? My godown data warehouse. So in our classes from tomorrow, we need to slowly step into 4 different items: data factory, Synapse, first 3 weeks. Then remaining 3 weeks, Databricks, Spark. 7th week, we need to mix them carefully, all possible combinations. That's our course. Let's make it meaningful. Need your support. Things are a bit vast, and let's make it clear and straight. I repeat, open source ETL, Microsoft ETL, open source ETL Databricks, Microsoft ETL Data Factory. And next, open source warehouse Spark, Microsoft warehouse Synapse. Single course, Azure Data Engineering. What about the source data? Source can be databases or non-databases. We need both. With this content, coming to our project work. In our classes, we have a good project for our resume. We'll start with unstructured data. So slowly proceed for storage, data preparation, staging, modeling, and serving. We need to learn Power BI connections. Core Power BI data analytics separate 1-month course. But as a data engineer, we should be having knowledge on how to connect. What to connect? Yes, these two, Synapse to Power BI and Spark to Power BI. Remember, Data Factory cannot be connected to Power BI. We cannot. Databricks we cannot connect to Power BI directly. Why? Because Data Factory and Databricks do not store data by themselves. They have dependent components called Synapse and Spark respectively. They store the data, and those are the houses for Power BI, data houses for Power BI analytics. We need to understand those connections practically step by step. With this content, let's recap once again what we are going to learn. A simple, straightforward process in our classes from tomorrow on my screen. We need to master the art of designing data structures to perform ETL, extraction, transformation, loading. Now, from where to extract? Yes, databases and non-database sources like apps, files, etc. Perform transformations and data loads. What kind of transformations? Yes, formatting the data, merging, union, filtering the data, etc. One of the examples in our classes will be taking something called CSV files, and we perform data loads. We'll take Excel data, perform filtering and data loads. And we have something called EPL match data, just like our IPL. IPL is new. The old one, we have something called EPL, England Premium League match data. EPL match data. And here, the EPL data requires something called year as a parameter. So using data factory, we can customize this item. We'll see how to supply multiple year values and get yearly football match data report, consolidate it, and store it in a warehouse for easy Power BI reporting. ETL, extract from websites, transform it, consolidate it, and load it to our required destination, a Spark database or a Synapse warehouse. Remember that. Next, in our journey, we come across practically we need to learn storage account like our hard disk to store files, tables, etc. Just like our hard disk. Okay, please by heart these new terms now. Storage account like our hard disk. Data lake storage like our SSD, solid state disk. Desktop has hard disk, laptop usually have SSD. Both are storage only, but main difference. Number two, data lake storage account has more capacity, more security, more faster, hence costly. We need these items from day after tomorrow. From second example, we have something called ETL staging, logging, optimizations, etc. We need them. And next, ETL components. Azure Databricks. We design something called notebooks. Data factory. We have something called pipelines. And these two are good friends. Next, data warehouse components. Your Spark databases that support Spark SQL. I assume we're all very new. We'll learn it slowly. Synapse warehouse, Microsoft product, TSQL. You're already aware of TSQL. Please revise the basics until joins. Enough. Constraints, joins, please be clear. And we have other helping components. Stream analytics job. What's the purpose? To read streaming data. Streaming data means live continuous incoming data. Example. One of our class examples I'll show you here. Something like this. We are going to learn how to read data from live IoT content. I have my new items here. Just wait for a few moments. Yep, here it is. We are going to read data from live temperature sensor through web applications to IoT. And there comes stream analytics job to read data from Internet of Things, write it to a storage or a warehouse, and from there to Power BI. My class notes would be in this way for every example, straight to the point, synopsis and task items. If we practice on time, we can pretty sure we can make it work. Task items you'll be submitting by weekend. But every day, please involve in your continuous practice. Need your support. Stream analytics job for live streaming data. It reads data from either IoT hub or event hub. What's the difference? IoT hub to capture live data. Event hub to capture near live data, near real time. Events, whenever they occur, we capture. IoT, continuous process. It keeps on occurring. For example, this temperature data I was mentioning, it is live, it's continuous activity. That is IoT, IoT hub. The other one, we have something called event hub. For example, we have something called Event Hub, and in Event Hub, we'll be taking something called phone call tracking. Whenever there is a phone call tracking, you would like to track it or you would like to capture it. Okay, something like this. I'll show you on my screen now. We are going to install something called Telco app to monitor the phone calls, usually detective agencies, security, government agencies, and detective agencies will use these kind of apps from Microsoft officially. So we install the app in our computer, generate some phone call data, and read it through something called Event Hub. In simple words, IoT hub, breathing, continuous process, right? Simple. Event hub, talking. Whenever you talk, I hear. Whenever I talk, you hear. That is event. I don't talk for a few moments. We hear nothing. That is event hub. Whenever there is an event, we track it. Breathing, continuous. If I stop it, I don't know what happens next. That is IoT. Remember, these examples, we need them for our classes. Next, logic apps. Very important for us. Mainly for automation of above components. Monitor, alerts. Monitor first, alert it, notification next. Security, we have something called key vaults. Key vaults are mainly for user-defined security. Microsoft Azure cloud-defined security was something called Microsoft Entra. In olden days, we used to call it Active Directory. So these are the main menu items for our recipe project work. Notes, material, I'll take care. Everyday assignments, I'll take care. On-time practice, I request you to take care. Certification. We have DP203 certification that is going to expire by end of this month. Then what next? DP700. It has Azure components and additionally Fabric components. DP700. It has Synapse, Data Factory, and other Azure components in addition to Fabric, Microsoft next generation cloud Fabric components. Now you can ask me, Sai, what's the difference between Azure cloud and Fabric cloud? Purpose is same. Remember, purpose is same. ETL and data warehouse, but the way we do it is entirely different. Interface is different. Architecture is different. Storage components are different. I must say everything entirely different. In Azure, in simple terms, let me give the difference. In Azure, it's like a la carte. We have to pay for data factory separately, PySpark separately, warehouse separately, and ADLS, Azure Data Lake Storage separately. Alerts separately, monitoring separately, key vault security separately in Azure, a la carte. Fabric is like a brunch, weekend brunch, buffet. Really, it's like a buffet. We pay as per our usage. We don't pay for them separately. And existing projects are safe. They are in Azure. So Azure has its own standard, streamlined, stabilized market. They are safe. Fabric is new. In fact, the licensing of Fabric is yet to be made public by Microsoft. They're still waiting for it. It's good to have Fabric, but there are many things just still in preview phase in Fabric. and the interface of Fabric is entirely different. Purpose is same. Remember, purpose is same. I repeat again, if you go for Fabric, in Fabric also we have something called Fabric warehouse creation. Here we say Synapse warehouse, okay? There it is Fabric warehouse. And here we have incremental and aggregated data loads. There also same concept. Here we have Azure Data Factory. There it is Fabric Data Factory, FDF. Here we have Data Lake. There we have something called Lake House. Purpose is same, to implement ETL and data warehouse, but the taking is entirely different. Not even one single screen or example will be similar. Trust me, things are different there. For me, Azure 7 weeks journey, Fabric another 7 weeks journey, independent of each other. I repeat again, you may have a question. We have Azure data engineering, Fabric data engineering. What's the difference? There is a difference. Azure is like a la carte. We pay for each component separately. I was showing you the components, right? These are all the major components in Azure engineering. In Fabric, the list of components are a bit less and we pay as a single unit. And none of them will be repeated there. The terminology is new, the products are new, the interface is new. Both have AI support. And from here, you can ask me, Sai, which one is better, Azure or Fabric? For me, Azure. If you are planning for experience in your resume, I would like to say experience and 2+ work experience on a project. You have to put Azure only, right? We cannot say 2+ on Fabric. We cannot. Fabric is new. Let's think practically. Azure is more stabilized, safe. Fabric new. There are a lot of preview options out there still. You may opt for Fabric after 6 months or 1 year down the line. Now, from here, what next?
Sir, I have a
We
small
need to
question.
slowly proceed for our Q&A now, and then we'll proceed for configurations. We need to do Azure lab configuration next to start our classes from tomorrow. Before we proceed, please go through item 1, what is engineering? Item 2, what is Azure engineering? These two items. Prerequisites. Please install SQL Server and revise constraints, joins, group by. Enough. Request you to have a debit card or a credit card from your end to activate your free trial, 30 days trial. After 30 days, another new friend, another account, another mobile number. In case you want to go for continue free account. If not, you will need to have paid account. It will be costing you about $40 to $50 per month. Say around 3,000 to 4,000 INR per month. Per month. In case if you decide to go for pay account. Free account is a preferred choice for our classes. Any questions now? Over to you. Please let me know. I'll wait. I'll show you the configurations. Please do them for tomorrow's class. Go to this website, okay? portal.azure.com. It says no account, create one. Click on create one. To start our Azure classes from tomorrow, the core engineering classes, please go to portal.azure.com. Okay, this one. Then no account, create one. It will ask you for email address. You specify your email address. You get a confirmation mail. You click on the confirmation link. Then it will ask you to sign up. It will ask you to choose a username and a password. Usually username will be your email address and choose a password. No extra prompts. You'll be able to sign into Azure like this. It's enough. We are ready for tomorrow's class. Tomorrow, we'll see how to get a free subscription and slowly start our class. We'll stop for today. Please log into portal.azure.com. Sign up, sign in. We are ready for tomorrow's class. We'll stop for now. Please make sure we have every day 1 hour practice, please. You'll attend the class. Let's make the class interactive and make sure you practice everything every day on the same day or before the next day, please. Let's make it happen. Things are very interactive and interesting here. Thank you. Have a nice time. And I'll be sending you now the detailed course curriculum and the items I was showing today in the class. I'll send you the PDF course curriculum. It includes SQL items also for your quick reference. We are concentrating on the Azure Data Engineering module from this PDF. I'll be sending you the introduction notes also and a small document on Azure fundamentals. I'll explain the things from tomorrow anyway. I'll provide you all this content now. Kindly go through it before tomorrow's class. Over to you. Any questions, please? I'll wait. Please let me know. I'll stay back.